Hi, my name is Adri Raju Subramanyam, Subi for short, and for the last 10 years I've been at Kansas State University in Manhattan, Kansas in the Department of Grain Science and Industry, and I'm a stored product entomologist by training. At Kansas State University I do several things. I have a teaching appointment, I have a research appointment, and I also have an international appointment. When it comes to my teaching, I teach a class every spring semester. It's called Food and Feed Product Protection, and the course centers around food laws and regulations that as applicable to the grain-based industries. And the course involves identifying physical, chemical, biological hazards in food and systems that are in place to eliminate systems, and as well as programs that are in place to eliminate those hazards. This course has a total of 40 lectures, and also it has labs associated with it. And it's a course where students do use the knowledge gained from it when they end up in the food industry. It's predominantly designed for undergraduate seniors and juniors, and also upper level graduate students take the class. And in our department, we have 100% employment of our undergraduate students that go into the baking industry, food industry, or the feed industry, and these people do use the principles that they learn in this class. So it is a very practical class, and what I've noticed as I travel around the world, that some of the same principles are used in every food and feed industry throughout the world. So it's a very relevant class, and I'm proud to teach it, and while teaching it for the last 10 years, I've learned a lot myself. Now, coming to my research, for the last 20 years, I've been focusing on using reduced risk pesticides or alternatives to pesticides for managing insects in the post-harvest systems, primarily not only for the grain, but also in the grain processing industries. Well, one of the research projects that we started 10 years ago, and we still continue to work to this day, is evaluating spinosad as a protectant on stored commodities. And based on our research over the last 10 years, spinosad was registered by the US EPA in 2005, and the international tolerances were set in 2006, and we're now testing pre-commercial formulations to be released soon by Bayer Crop Science. And the other thing I've been working on for the last 10 years is looking at alternatives to pesticides, or specifically methyl bromide, for managing insects in flour mills and feed mills, and that involves using high temperatures to kill insects as an alternative to methyl bromide, because methyl bromide was phased out in the US as of 2005, and heat treatment, which is a 100-year-old technology, was predominantly in art, and over the last 10 years, through research and training programs we have shown that it can also be is science, but it'll always be a combination of both art and science. Over the years, I think all of us need to look at our programs, and especially when it involves working with insects in the grain and food industry, where some of these products are processed to human food. Some of the entomological aspects can be integrated with food safety issues, and that's exactly what I have done with my program, because the good manufacturing practices, or the hazard analysis critical control points program that companies use to be in compliance with food safety issues, have pest management as a component of it. So as I travel around the world, and also when I do my research, we're trying to focus on some of the food safety issues. For example, over the last 6 years with 2 students, we have looked at enterococci bacteria. These are secondary pathogens. They only affect immunocompromised individuals, but these enterococci bacteria are present in stored product insects commonly found in food and feed plants, and also in grain environments. And we also have sampled products, grain products. We've sampled milled products from some of the facilities, and we've shown that they contain antibiotic-resistant and potentially virulent enterococci in their midgut. And these have shown high levels of resistance to antibiotics that are used in clinical settings. So we have now shown that these insects are not just an aesthetic filth in our food and feed plants or in our grain, but also they carry potentially antibiotic-resistant virulent bacteria that can then transfer the genes in our intestines or in the animal intestines to more serious pathogens like E. coli or Salmonella or Staphylococcus. So we have not come to that stage to show horizontal gene transfer, but we have done laboratory tests to show that horizontal gene transfer does occur, and some of the insects that we have, store product insects, are competent vectors of these pathogens.
Thank you very much.
Thank you.